Hi everyone, welcome back. So now we're going to discuss quantum numbers. So we have the concept of orbital very clear in our heads, and we know how it is different from an orbit. So now we're going to discuss about quantum numbers. Now the topic of quantum numbers should really be very clear. It's something like if you are still going to take a few chemistry courses or even for just one course, you really have to know how quantum numbers work. Extremely important. So quantum numbers, what are they? So like I told you, an atom consists of a lot of orbitals. There's tons and tons of orbitals in an atom depending on how many electrons there are. So every orbital in an atom is distinguished from another one on the basis of its size, of its shape, and its orientation, which means its direction in space, right? So orbitals differ from each other in terms of their size, how big and small they are, shape, and their orientation, and energy as well, right? So these different parameters differentiate one orbital from another. Now, the different parameters of these orbitals are described by these quantum numbers. Okay, that is the technical way of describing quantum numbers. Okay, and these quantum numbers we have, like I mentioned in the first video, we have the principal quantum number, we have the second quantum number, we have the spin quantum number, and then we have the magnetic quantum number. Okay, so in terms of electrons, when we describe quantum numbers in terms of orbitals, what are quantum numbers in terms of electrons? And they're not different, it's just different ways of expressing, of defining quantum numbers. The quantum numbers give you the exact location, or in other words, they give you the complete information about all of the electrons in an atom. What kind of information? Size of the orbital they're in, shape of the orbital they're in, orientation of the orbital, and the energy. Okay? The quantum numbers are defined as a set of four numbers with the help of which we can get complete information about all the electrons in an atom, that is location, energy, the type of orbital occupied, and the orientation of that orbital. Okay, so those are quantum numbers. So they're sort of like a good analogy is thinking along the lines of a postal address. So if you need to send someone a mail or a document, then you need their postal address. The postal address is going to help you identify their country, their city, their province, their house number, their lane number, and so on, right? So you start from really big and then you go all the way to house number. That's how quantum numbers work. They're really the address of an electron. I like to think of it as that. Address of an electron. So quantum numbers are a very fundamental concept and we should really know it very well. So let us begin then. The principal quantum number, change the color. Now, the principal quantum number is the most important quantum number. It tells you about the principal energy level or the shell to which the electron belongs. Okay, so it is the most important one. It is called principal quantum number, and it is denoted by n. And it tells you about the shell, right, or the orbit to which an electron belongs. Okay, and n can have any integral value except for 0. So you can have n greater than or equal to 1. Okay, so you can have n equals 1, 2, 3, 4, and so on. Depending on the number of electrons, we can have as many principal shells. Alright, and they're also denoted by the letters K, L, M, N, and so on. But this is not really used a lot anymore in courses, so we're just going to refer to them as 1, 2, 3, 4, the respective values of n. The number of the number of n, actually we have 5 seconds left, so I'm going to continue this in the next one.